Hi guys, welcome to Tactic Apps. In today's tutorial, I'll be showing you guys how to create this bouncing loader custom control in WPF. Now this is the first video in a series of UI loaders created in WPF using the C# language. To create this loader control, I will start by creating a border, setting its width to 200 and its height to 10 pixels, then set its corner radius to 5 pixels, which is half its height. Then I will create a rectangle with a height and width of 10 pixels and set its radius X and radius Y values to 5 pixels to give it a round shape. I will then place it inside the border I created earlier on and set its horizontal alignment to left. Having said that, all that's left is animating the X position of the rounded rectangle from left to right and back to left. This can be done by animating the X property of a translate transform and then applying it to the rounded rectangle. To achieve a stretching effect, we can animate the rectangle's width as it travels along the X-axis. We can set a maximum width when it reaches the midpoint and then set a minimum width when it reaches the end. By doing so, this will achieve a stretching effect caused by inertia. Without further ado, let's dive into the coding. Now, with a project already set up here, I'll go ahead and add in a custom control. And I'll give it a name of bounce loader. Alright, now Visual Studio has added in the appropriate class as well as a resource dictionary that contains our style. Here, you can see the style defined here. Now, within our style, we already have a border set up here, so I'll just go ahead and give it a name. I'll just give it a name of bounce background. And I'll set its width to 200 and its height to 10. Then I'll set its corner radius to 5. Okay. Now within our border, I'll add in a rectangle and I'll set its fill to a shade of orange. I'll set its height and width to 10. I'll set its radius X and radius Y values to 5. Okay, then I'll also set its horizontal alignment to left. I'm going to give it a name as well, so I'll give it a name of bouncer. Okay, so I'll go to my main window and add in my control. Now before I can add in my control, I'll just go ahead and build the solution. Alright, the solution has been built successfully. So within my grid, I'll just add in the name bouncer and here it shows up. Now we can see that our control is only appearing as a dot. So that's because we haven't defined our background color for our border. So I'll just set our background color to a shade of gray. And you can now see its appearance. Okay, so what I need to achieve now is I need to animate this rectangle to move to the right and back to the left. Now I'll be doing this in the code behind. I won't be defining my animations in the XAML file. So I'll go back to my class here, which is the bounce loader class. And I'll just get rid of this summary. Okay, and I'll change this static property to a public property. This is important because it allows us to access the events of our control. Now within our control, there is an event called the loaded event. So So this event happens whenever the control has finished loading. So I'll subscribe to this event, and here we see this method. So what happens is whenever the control has finished loading, this method will be executed, and this is where I want to define my styles, my animations, sorry. Okay, so I'll go ahead and create a double animation. And I'll add in the appropriate namespace. So I'll just give it a name of animation 1. Now our target value here that we are trying to animate is the X property, which is the translate X property. So I need to move this rectangle to the right. Now, since we know that our background border has a distance of 200, we will animate our rectangle to a distance of 190. Now, the reason why we subtracted 10 is because the very rectangle has a width of 10. So we can't exactly animate to 200. That would cause it to overshoot here. So I'll set my target value to 190, and I'll set the duration of our animation to 1 second. Okay, now our animation has been set here, but I also want to set a few properties of this animation, like the repeat behavior. So the repeat behavior will be set to forever so that it keeps on animating. And I also set the auto reverse to true. Now the reason for setting our auto reverse to true is because when our rectangle animates to a position of 190, it has to go back to its original location. So if I set the auto reverse, that will happen automatically within the animation itself. And I'll also set our easing function to a new cubic function, new cubic ease. Okay. And I'll set the easing mode to ease in, ease out. So what this does is it causes our rectangle to slow down as it approaches the final value, and also causes it to slow down as it approaches the minimum value, because we are saying ease in, that's our minimum, and ease out, that's when it approaches our maximum. So it will have that slowing down effect as it approaches the target value. Okay, so I've created a double animation. I've set our target value to 190, and it's going to animate for 1 second. Its repeat behavior is forever. The auto reverse is set to true. The easing function is set to ease in, ease out. I'm using this class called the cubic ease to achieve that ease in, ease out function. All right, so what I'm going to do is I'm going to copy and paste this animation. Now the second animation is for our width as it moves along the x-axis. So I'll give it a name of animation 2. Now I want our width to reach a maximum value of 40, and I want that to happen when our animation is at its midpoint, which is here. Now since our rectangle is moving from the left to the right within 1 second, so for me to have my maximum width set at the midpoint, I need to set the animation to 0.5 seconds. So as I'm moving through the X, when I reach half, which is 0.5 seconds, I want it to reach its maximum value of 40. So I'm going to set our duration to 0.5 seconds. That's when I approach this maximum width. Okay. So once the maximum width is approached, as I move further, it will reduce again and it will create that stretching effect. Okay, so that's it. The two animations are set. So what I'm going to do is I'm going to create a translate transform, and I'm going to give it a name of trans. Okay, and I'm going to animate this translate transform's X property. So I just go trans dot begin animation. So the translate transforms X property, and I'll set its animation to animation 1 here. So this is our translate transform, and I'm animating its X property, and I'm using the animation 1 here, which I created. Okay, now what's left for us to do is I now need to access this rectangle here from our style. So for me to do that, I'm just going to type in template. So within our template, there's a method called find name. Okay, so I can specify the name of our element and I'm able to retrieve that element. So in our style here, we have given it a name of bouncer. So I'll just go ahead and so it's of the name bouncer, and this template is actually applied to our bouncer class here, our bounce loader class. So I need to define which templated parent it is. So since it's our class here, I'll just put in the keyword this. Okay, so I'm retrieving our bouncer element through this function template.findName. Now, since I already know that my bouncer element is actually a rectangle, so I can explicitly define it here. So I'll just say rectangle. I'll give it a name rect. So we know that the element coming back here that is returned is actually a rectangle. So here we need to create a cast. Okay, so we have explicitly defined the return object here, and that's our rectangle there. So what I'm going to do is I'm going to set the rectangle's render transform to our translate transform. Okay, so here we have a translate transform, and it's been animated from left to right. Its X property has been animated, so that has already the animation has already begun. So now we set this translate transform, we assign it to our render transform here, so that our rectangle can now move from left to right. Now we also need to animate our rectangle's width property, so we can do that by just using the begin function, and we specify our target property, and here it's the width property, and we set our animation, which is our second animation here, that reaches its maximum when it reaches the midpoint, which is 0.5 seconds, and that's our animation. Okay, so let me just do a quick review. So we have defined two animations here. So one is of a duration 1 second, the other is of half a second, and we've created a translate transform, and we've begun to animate its X property here in this code, and we have retrieved our rectangle, which is in our template, and we've set its render transform to this translate transform, which is being animated. We've also begun animating its width property using the second animation. So this should achieve the appearance that we are looking for. So I'll go back to my main window, and I'll just build the solution, and we should see this start animating. Okay, So now you can see it animating from left to right, and as it reaches the midpoint, its width increases to give it that stretching effect caused by inertia. Now this happens because we placed all our code inside the loaded event. So whenever it's loaded, our function starts playing. So this is what we have. Thanks guys for watching. See you in the next video.